In this video, we're going to learn how to factor trinomials and binomials completely by first factoring out a greatest common factor, or GCF. Let's check this out. So the instructions are factor. Sometimes you'll be given the instructions factor completely. So no matter what I want you to now put into your repertoire, right, your process for factoring is always look to factor out a GCF first. The reason being is, when you factor a GCF out of any polynomial, all of the coefficients will reduce, they'll get lower, which lessens the amount of options for factors that we'd have to go through. It greatly reduces the amount of work we have to do. Okay, let's check it out. So here, we've got a GCF of 4, because 4 goes into itself once, goes into 8 twice, and into 60 15 times. So start out by factoring out the GCF. And if you're looking at this saying, I don't remember how to do that, watch my earlier videos on how to factor out GCFs before you check out this video. All right, so let's do it. So 4 times v squared gives me 4v squared. This is going to be a minus. 4 times 2v gives me 8v. And then 4 times minus 15 gives me 60. So right away, we're in really good shape. This is much easier to factor, and we can factor what's in the parentheses still. Very important, and a common error that students make is they often leave out this 4. They just kind of erase it after this part, and they're like, I'm done with it. If you factor 20, let's say, and I'll do this over here. Let's say that you factor 20 into 4 and 5, right? So 4 times 5. And then factor the 4 into 2 times 2. You don't then tell me that 2 times 2 is equal to 20. 2 times 2 times 5 gives you 20. My point in bringing that up is all of this work right here, that 4 is like that 5. It's the first factor that came out. It still is needed to multiply back to that. So keep it there. Okay, now we're going to factor out v squared minus 2v minus 15. Just focus your brain on that part. So we have a v and a v. The leading coefficient is now 1. So we're green lighted, or green lit maybe, to look at this and say, you know what? I'm looking at factors of 15 that add up to negative 2. The numbers that multiply to 15 that combine to give me 2 are 5 and 3. And if you're having trouble with that step, go back and watch my videos on how to factor out trinomials with the leading coefficient of 1. So this would have to be negative and that would have to be positive, because negative 5 plus 3 gives us negative 2. Okay, so now here, if you wanted to check your answer, all you would need to do, and I'm not going to go through and do it, but I'm just, well, you know what? I'll do one of them. To check your answer, you multiply through. And it doesn't matter what order you multiply in, but I suggest that you multiply these parentheses first and then by 4. So all I'm doing here to check my work is doing v times v is v squared. V times negative 5 is negative 5v, plus 3v is negative 2v. And then 3 times negative 5 last is negative 15. Then when I multiply by 4, I get 4v squared, check. 4 times negative 2v, negative 8v, yes. 4 times negative 15, negative 60. All right. So you can check by foiling, and then don't forget about that first factor you took out, the GCF. All right, in letter B, again, there's a GCF. We're going to pull it out. We're going to pull out 5. So I pull out the 5 from each of these terms. That's the GCF. 5 times 4 gives me 4x squared, right? Or it gives me the 20x squared back. 5 times, you might need a calculator. 80 divided by 5. If you need it, that's fine. That's 16x. And then 5 times 7 would get me back to 35. What we have now done by pulling out the GCF is we now have lower numbers. That will allow us to factor this much, much quicker. So I've got 5, that doesn't go anywhere, right, times, and now my brain is fully focused on factoring this. And I'm going to do this pretty quickly. So if you're having trouble factoring where the leading coefficient is more than 1, go back and watch the videos for leading coefficient more than 1 and rock that stuff. So I'm going to start out, as I always do, with 2x and 2x, and I'll do some guess and check. Now here's the good news. I know that the only factors of 7 are itself and 1. So let's test it. 2x times 1 is 2x, 7 times 2x is 14x, and 2x is 16x. If they're both plus, we'll get the plus 7 by multiplying 7 and 1, and the positive 16x. So we're good. To check your work, we would do the same thing here. You'd multiply this part out, and then by 5, and you should end up back where you started. Factoring out that 5 greatly reduced the number of options that we needed to use when we were using our method of guess and check. All right, now this one is an awesome one. I love this one. If we have a GCF here, then we should factor it out, right? And we do. 7 goes into 28 in itself. So I factor out 7 times m squared gets me back to m squared, 7m squared, minus 7 times 4 would get me to 28. Nice. So now I go to the inside and my brain is fully focused on this part. So the 7's along for the ride. And I'm looking at what numbers multiply to give me 4 that essentially add to 0m. So I know there's m and m. And then we're looking at it and saying, oh, well, the only factors of 4 are 1 and 4, but they don't combine to give me 0. 2 and 2 do. So this is going to be minus 2 and plus 2. Donezo. It's sweet. Sweet. GCF-ness. All right, we'll do one more factoring out the GCF, and then I think that'll be enough for you. So we look at this problem. The greatest common factor is 3. So 3 goes into 18. 6, and you know what? Let's make it a little more, I'm going to make it a little juicier. I'm going to make it a little juicier. Why not? I'm going to make this z to the 3rd. I'm going to make this z squared, and I'll make this z. So now the GCF is 3z. I can pull out a 3z from the whole thing. 3 times 6 gives me 18, and it would have to be 6z squared to get me back to 18z cubed. Plus, this would have to be 11, because 11 times 3 is equal to, looks like an H with that little mark there. 11 times 3 is 33, times z gives me z squared, and then 3 times 10, negative 10, getting back to 30, and the z is already there. So now, to keep going with this, I just keep the factor of 3z on the outside, no sweat, and now I'm factoring what's on the inside there. Now, I'm going to start with 3z and 2z rather than 6 and 1 to try to test my values. I start with lower numbers first when that middle number is relatively low. Factors of 10, 1 and 10, 2 and 5. I'm going to go with 2 and 5, again, because 1 and 10, that 10's kind of a high number. Okay, so I could be wrong, but I'm going to go with 2 and 5. So I'll start with a 5 here and a 2 here. When I multiply those, I get 6z and 10z, which are not going to get me to 11. It's going to get me to 16, so 10 and 6 or 4. So I'm going to flip them, erase that John, and erase that John right there. That's a Philly term for that thing. And if you didn't know, that's where I'm from. So anyway, we're going to flip and flop those values. So now we'll put a 5 here, and we'll put the 2 here. Now here we get 15z and 4z. If I then get a positive 15z and a negative 4z, that will add to 11z. And then we're perfect. And we're done at that point. To check it again, you would FOIL this and then distribute in the 3z. So when you FOIL this back, you should get here, multiply through by the 3z, get back to here, and then you know that you're right. Moral of the story, factor out the GCF and you will be in great shape. Greatest shape, common factor. Get that joke? See you next time.